Okay, so as you're looking, I will quickly introduce Maria. So Maria has worked in conservation management and spatial planning of marine ecosystems for 2 decades, so she's quite an experience. And she has a special focus on tropical and subtropical systems. So Maria, the floor is yours.
All right, now that I've worked out how to unmute myself, we can get started. So I will talk about more or less the first bit here, importance of marine functional connectivity in environmental decision making. And of course, that includes what Elena talked about, marine spatial planning. And so I start off with telling you what it is, although it's probably quite, I should maybe just go and have a coffee instead of talking to you, because you already all know what connectivity is. And so maybe I don't have to talk too much about it. I'll talk about how that might be used in spatial planning and how we could maybe overcome the policy and implementation gap in using connectivity to inform decision making. So let's start off with what it is. Is that right?
Yeah.
Yeah, sorry.
It's always good to have a reminder anyway.
Yeah. So what is connectivity? And it is the flow of organisms, matter and energy. And I think we often focus on the flow of organisms, of course, because we're familiar with things like migratory movements, ontogenetic movement, which is, species needing to use different habitat types or different locations throughout their development from being juveniles to adults. We know that in the marine system, propagules disperse, and that's a major driver of things like recovery and population connectivity, so also evolutionary patterns. And of course, connectivity can also be a bad thing in terms of disease spreading or invasive species that spread throughout a marine ecosystem. Matter perhaps is something we think less about, but at the same time, the dispersion of pollutants is obviously really important to consider when we make decisions. That's, we talked about that a little bit earlier. We sort of need to think about, or with decision makers and policy makers, we need to think about what is the purpose of protecting things and can we achieve it? There's always the background of, are we actually able to make a difference in this location? And pollutants are a big problem. You can't fight pollutants by putting a protected area. You obviously have to work at the source of the pollutant, which might well be on land that you don't have jurisdiction over when you're a marine manager or marine policymaker. And then there's really important processes where leaf litter or other matter can move downstream or somewhere into, within the circle through upwelling, providing nutrients that are crucial for an ecosystem. And similarly with energy, well, what's the difference between matter and energy? We could split hairs about it. But for example, if you're thinking of carbon being cycled and being transported by both currents, by species and various other processes to contribute to nutrient cycles, but also to carbon uptake. So there's many processes that are really important with respect to connectivity. And I just wanted to highlight that there's various it goes beyond species of when we think about connectivity. I want to now focus on what is functional connectivity. Well, we know marine connectivity is obviously connectivity in the ocean. Functional connectivity is the realized movement of organisms. So while there could be a certain structural connectivity here given by the two patches that are, in this case, not connected at all, or there's space between them. This could be habitat patches that are, they're separated by sand, for example, or two islands are separated by kilometers of sea, or there could be a small connection. And so this is really just an example to show what the physical characteristics of a landscape or seascape are really important. So is connectivity possible structurally? And in the ocean, that is often driven by currents. So are the currents going in the right direction, basically? But of course, that is not all of it. It is the main question now is, are you able as a species or as a process to traverse the gap between those two patches? And a species that has a large maybe home range or a large ability to move around can easily go from one patch to another. Like this might be a bird that can fly from one island to another. Or it could be a sea turtle that can go from one place to another. But there could be other species that actually don't have the ability to go from one patch to another, even where they are connected, because they don't have the ability to migrate through the corridors that do exist, or use the ocean patterns, the circulation patterns that are present. And so functional connectivity is really the realized movement and is species dependent. But of course, the structural connectivity is underlying and underpinning this, because we obviously need to, each species is still subject to the habitat. Connectivity has many, many names and works at many, many scales. I've already given some examples. Here's just a list of ways of how people have talked about connectivity. And effectively, I would argue that it's always functional connectivity that people are interested in, because structural connectivity does not actually achieve genetic, ecological, and so on connectivity. So now that we know what it is, we want to think about marine spatial planning specifically, but maybe managing marine environments more broadly. And first of all, and I was quite intrigued by the question by Janair about mark science, a black box. We don't see what kind of goes in, we only see what comes out. And I think one of the key questions here that we need to have as a precursor to running a spatial planning in the software is to think about, well, what is it actually we want to do? What's our objective, right? And that really depends on our context. And when we think about species that move or migrate or larval dispersal, for example, a typical goal could be to manage the complete life cycle. And so when I'm talking about later how MFC is not often used by marine managers, it is really that I'm concerned about those goals and those objectives. People very rarely think about connectivity, making connectivity part of their conservation and management goals. So recruitment, of course, and gene flow could be is a key of objective in many conservation plans or management activities, where we're aiming to recover any damaged areas or set up a protected area network in a way that any damage can be recovered in the future. And then, of course, on the opposite end, bad connectivity is something we want to avoid. So on one side, we have objectives that can encourage connectivity. On the other hand, we actually want to stop invasions and want to ensure that we can set up protected areas or management actions that avoids disease spread. And so this is nice and sounds good, but of course it's super hard to do, because half of the time we don't know where the connectivity patterns go and how strong they are. It's very difficult to sort of work it out. But also we always have multiple objectives, multiple purposes, and it's very difficult to, on one hand, connect life cycles and larval dispersal, for example, but on the other side, also stop invasions, because you kind of looking at the same processes, just one of them encourages what we want, the other thing hampers what we want. And so I'll jump to some examples to stay within time here. Let's think about spatial planning for sea turtles. This is not, unfortunately, an example from the Mediterranean, because I haven't worked in the Mediterranean, but this is a sample from the Coral Triangle. Coral Triangle includes Indonesia here, Philippines, Papua New Guinea, Solomons, and Timor-Leste, which is in here. And here we've got 4 turtles, and they all have nesting beaches somewhere on the coast, and then they have a track that goes to their foraging area. And so I think the longest turtle is this purple one here that goes from Malaysia all the way across Borneo, and it kind of meanders around here, and then it heads over into Papua New Guinea over here. I hope you can see my cursor, but so they have a huge migratory pathway, and of course they get caught while they're migrating. They get caught because they're being targeted, but they're also getting caught by accident. And so if we want to protect the entire life cycle of the turtles, we want to actually think about multiple objectives or ways of dealing with it. So one way, of course, would be to protect parts of the foraging area where they go and feed, and parts of the nesting beaches, which of course we stop people from collecting the eggs, which is the biggest threat historically, but now it's also sea level rise washes out the nests. But we also need to protect the pathway, because of course, if the turtles can't go from A to B, then they're still doomed, and we're still not achieving our protection goals. I'm pretty sure most of you know about how larval dispersal works. Here's a reef on the left. Fish go and spawn, and their larvae can go to other patches. And in some years, they might be able to come to a certain patch that they can't achieve to get to every year. And so connectivity can be driven by currents. Larvae disperse as part of a sort of relatively inert particles until they develop the ability to swim towards their patch. But also other populations at the other side can go back. So it can work in either direction. And often is much more complex, of course, if you have a whole seascape of dispersal. And the main thing I wanted to point at right now is not how we're working out those patterns, but how they can really differ for 2 different species. And so there's species with really contrasting life history patterns. So whether they disperse well, so how long is their dispersal phase, a dispersive phase, how many what's the mortality as they're dispersing, how easy is it for them to settle. And you can see the sea cucumber here in those within that region has much shorter and fewer dispersal events that they can rely on. And the coral trout, which is a fish that has, so the sea cucumber has about 9 days in the water column. The fish has about 30. It gets much further. It goes around more. It has the ability to be a much better disperser. And when we think about integrating this into spatial planning, we then need to think about, okay, which species do we want to capture? And do we actually want to capture the bad dispersers and the good dispersers? Or do we want to be somewhere in the middle? Do we want to focus on species that are relevant for fisheries, or maybe not so much? And so how we focus those questions really determines what we do, how we're putting our data into marksland, for example, or some other way of working out where to protect things. And so it is also quite unintuitive potentially when your different goals could be about maximizing larval exchange between protected areas, because that enhances persistence of biodiversity, or we want to support fisheries where we maximizing the spillover of larvae into unprotected sites where the fish can be fished. And so you would think about persistence benefit. You want a protected system that's really well connected, and so you protect those 2 things that interact very strongly with each other. If you're worried about spillover, you actually want to protect areas that enhance other areas as much as possible in order to enhance the fisheries in those outside areas. And so how you set your objective or your goal is really important, and that's where the policymakers come in, I think, where you have to talk, have to establish a dialogue, and like what Chris was saying, you have to have a level of trust to have a dialogue that addresses those questions. And I have been in a room actually in Australia where we've had the fisheries people and the biodiversity people in one room, and this discussion of what is the preference, it was a very heated one, shall I say, that involved shouting and banging doors, because people have their preferences and their expectations that it's very difficult to address, find a consensus sometimes. And so how to deal with bad connectivity? Here's an example from the Mediterranean, where we had a viral infection on the west coast on this the fan mussel, and that is there's a sort of outbreak heading towards the east, and that can be, of course, documented, and it's documented in this paper here, but it still is very difficult to think about, okay, how do you manage this kind of thing? How can you manage and think about these invasions? And we can look at connectivity models and measurement to think about at least areas that are least likely to be affected because they're actually not connected to the trajectory of the disease. And another idea could be with invasive species, like the lionfish, to knock out places that would be hubs from where those species can spread even further across the Mediterranean, for example. So identifying places where it's most effective to put your management action here to avoid spread. Oh, okay, that's not good. It swallowed my slide. And so I just want to go back to this sort of a finish up to try and highlight that it is actually really difficult to deal with policymakers. So I had a slide that shows how there is not that many cases in, I think it was the US, it was France, Australia, and another country that I've forgotten, where Metaxas and Berger looked at to what degree connectivity is represented in management plans and alongside other objectives that are, ecological objectives. And so connectivity was only present in a fraction of management plans. I'm going to say 5% because I haven't got the slide in front of me. And so that really indicates a big gap between these great ideas and the studies that have addressed connectivity theoretically and in a sort of developing a planning approach and methods and so on, but very little uptake by actual implementers, policymakers, and managers. And so what I wanted to put out for discussion actually is to maybe think about a little bit about what the boundaries are or the problems are with this. And so one of the issues is, of course, that connectivity is very difficult. It is very difficult to model and or measure because, of course, larvae are tiny. We can't see them. We don't know where they're going. Same with disease pathogens. We can't see where they're going. We just see when they arrived somewhere. So it's very difficult to anticipate where things might be going. We often don't know how their ecology and the local patterns of ocean currents and so on, how they could connect. And especially with invasive species, we don't actually know how their ecology works in a new place. And so we actually might under or overestimate what they are able to do. There's also a significant barrier in the technical side of things. It is really technical often to get those connectivity estimates. And even though it would be easy to convince a policymaker and a manager that it's really important to think about connections between places and in support of our conservation objectives overall to maintain biodiversity or maintain a species or habitat, the next question will always be, so how do I do it? And then their eyes glaze over when we begin to start about how we could measure it and how uncertain everything is. And so it is very difficult to go from the science of working it out to actually providing a really easy pathway by which we can explain, go beyond the benefits that everyone I think understands, but actually then go and work with managers and work with policymakers on, how can we kind of standardize or make it easy to address a really difficult issue. So if a policymaker or a manager, someone who is concerned with making decisions, like everyone in the world, we're not really keen on making our life harder than it already is. And so it is very, the key step, in my opinion, is to work out how can we get those sort of ecological realism packaged or provided in a way that it is easy to implement something that relates to that. And so I'm sorry, I totally messed that up, didn't I? The slides are here. Anyway, I'll run through them quickly because I'm running out of time and I want some time for questions. So here's a research effort on population connectivity. You can see the dark countries have lots of papers on it, but mostly incorporating connectivity into the design of areas, not necessarily implementation of that. Here's the paper I talked about. There you go. You can actually look at the percentage. I've got a totally wrong. It's about 15%, 10, 12, maybe something like that. But you can see compared to other ideas that we know more about, like biodiversity, representation, species at risk, spawning areas, and so on, connectivity is very rarely considered, relatively speaking, in those plans, in those countries. So yeah, so that's the last slide I already was talking to. I'm sorry about that. Here we, I guess I want to come back to maybe another point, which is translation, where it is really important that we, the scientists and policymakers, spend time and effort on actually talking to each other, because each group would use very different terminology, and that is not even just between scientists and policymakers. It's also between the different marine functional connectivity scientists are using different methods, for example. And there's also some reluctance of people to share the data, which, for example, with satellite tracking studies, that's a major problem, that it's so expensive to create the data. It's often very difficult for people to share them or let go based on their funding mechanisms and their various other sort of commitments. And so while I've talked about connectivity being really important for spatial planning and in general environmental management, actually there would be times when it's not. So I would argue that it's not always important. There's places when it would be a complete waste of time to implement it, because it is a big effort to get the data, and it might actually not work at the scale at which you're planning or thinking about implementing conservation. And so I'd be interested to have a discussion to work out what do you think about it.
Thanks a lot, Maria, for your presentation. And I know you have little time, but do we have questions or suggestions? Any reactions?
We don't have a raised hand right now, as far as I can see.
I'm Elena. Can I just add?
Mm-hmm. Yeah, absolutely.
Yeah, I'm very, very, very happy for the message that Maria reinforced and put forward about what are you modeling for, what you're doing for, because if you answer that, this is very crucial for us as a scientist and to interact with decision makers. So And these in a way set a lot of the decisions that you are going to take while modeling. I also really appreciate the point that Maria said about think about the disease that you are going to model or to spend time for, and money and effort is really needed, or if it is too difficult, because sometimes we see also that not necessarily that, like, there is something that is not really something that anybody can grasp or are not useful for the decisions that we have to make. So I really appreciate a lot of these 2 points.
So I have an example really briefly from actually Indonesian to sort of reiterate that point, where I was involved with an NGO working in an area in Indonesia to deal with connectivity and thinking about that fisheries objective that I mentioned earlier. And we went through this process of modeling and going around and consulting stakeholders and everything. And then after about a year of all that, they sent a data set where they've sent a team around all the islands as much as they could to look at the quality of the habitat, so the coral cover. And it turns out that it's only about 20% of the area that it still has intact coral cover. Everything else has been dynamite fished, so it's destroyed or quite damaged. And so that makes me, of course, quite cynical about it, because really, if we have model connectivity, assuming that is all the habitat is intact, then we could use that. But if all the habitat is destroyed and only 20% of it are intact, then obviously we should be having a totally different objective. Now our objective should be, where can we protect intact habitat to try to optimize or establish the reseeding of other habitats, right? And so that makes a big difference in how you think about your question. Right, so are there any other questions? Or
Yes,
maybe we can
have one. We have Lucia Giorni.
Okay.
Yes.
Okay. Very interesting talk, first of all. And I was wondering if to try to link the environmental issue of connectivity with the policy could be an idea to also show what could be if, starting from for sure cases that are very known about connectivity, for example, case studies, to show them what really would be to break the connectivity issue and what will be in terms of economics linked to, for example, resources and seedling of population, gene flow. So to show the reverse, like showing that if you break this, you really get very big trouble in managing the resources on which they live. So this could be probably an exercise that could be interesting for scientists to show. Of course, we have to start from very well-known cases of environmental studies that we know very well how they works. That is not easy also.
It's a great idea, actually. I like it, to actually think about if we work in a place that's without thinking about connectivity, we might protect one kind of population or community if that gets somehow damaged or through a storm gets trashed, whatever. If there's no other site that can replenish that site, what's the economic value of that site lost? One of the tricky issues with this, I think, is the time. So replenishment and recovery processes sometimes take really long time, depending on the life cycle of the species. And decision-making cycles are often very short. So telling a politician and even a policymaker that a benefit will come in 20 years is very often not an argument that will win. It's more about short-term gains. And so that is a tricky thing when it comes to networked planning, I think.
Thank you, Maria. I don't see any raised hands anymore. So Chantal, do you want to?
Okay, I'll go away.
Peter, we have
Okay.
Peter.
Sorry,
Thinking.
I was fighting to raise a hand, but I couldn't find it.
Then we saw it like this.
Yeah. So this is the old school.
School. Go ahead.
Just listening, Maria. Thanks very much. Really interesting. And listening to that last comment that you made, where do we stand when we talk about marine connectivity if we're going to talk about conservation burdens? So if we have certain connectivity, and generally when we talk about higher biodiversity areas, they tend to be less developed areas. So for instance, Eleanor's paper about the Adriatic identified that the lower cost areas to, if we're looking at a transboundary situation, identified that the eastern coast would be the, correct me if I'm wrong, Eleanor, but as I seem to remember, it identified certain areas that had lower conservation costs with regards to the Marksham planning. How do we stand also with integrating conservation burdens, and who's going to lose more from applying conservation, and who's going to gain more when you talk about a transboundary or connective environment? Thanks.
In some ways, connectivity might give an opportunity to reduce the burden on a certain area that is less developed. If you think about the potential interaction of many sites where each, say, community has a smaller conservation area that, you know, gives a burden to that community. But by and large, of course, if you have a part of your landscape or seascape that is quite heavily industrialized or damaged, and another part that's intact, there's sometimes not really that much point to actually assume recovery of those damaged areas unless they are, you know, they have that's a reasonable assumption. So that is, I guess, one of the issues to look at there is what do people want? You know, and are we planning at a country scale, on a regional scale, and to what degree are local people or nations or whatever sort of independent or sort of in their stewardship and their decision making? I think it's a really tricky thing that you bring up there, Peter, because it is really difficult, right? Connectivity just adds one more criteria that's out to put the burden on people that have looked after their place, or places that have no people to look up, you know, where it's very remote, and it takes away. Well, I think though we could argue that in some situations, connectivity would be a consideration where we say, let's protect an upstream area with the purpose of also protecting a downstream area that's currently damaged, so that we can spread the burden. So I can see how it would go either way, right? Be a positive thing or not.
Good, yeah. Could you potentially see payment for ecosystem services, for instance? You know, the downstream beneficiaries having to pay upstream the people who are paying the conservation burden.
Well, I have a question back for you then. When you're investing, how much certainty would you like that your investment is actually sensible? Right? So it leads back to how certain are we that we got the connectivity right, and that we are we more certain about that than that we are certain about the risks that's associated with actually having a damaged ecosystem?
Good point. And we have, I believe we have an environmental economist on the call. Right. I don't remember who it was, but I believe there is one. And at that point, I'll duck out.
This is a great discussion, but my students have been waiting for 19 minutes. I've got to go now. I'll talk to you later.
Anyway, we'll have some time to discuss all this probably on the third day. So nice.
Apologies, just Dania also has her hand raised. I don't know if she wants to connect to Maria's presentation.
Yeah, certainly. I mean, the discussion that's coming up is really very interesting. So how to tackle different issues. So I think connectivity is one added element that needs to be put in the heart of any pre-planning environment. No, so connectivity is one, but of course it's not everything. There needs to be an ecosystem function that is ensured as a basis for any decision. So I think it's more than one angle, but certainly connectivity is very important whenever it comes to also connecting what the discussion is starting, these upstream or these coastal marine connections, no, that are normally not very much set when you take these decisions. So certainly it's a very important input to planning, but I think that it needs also to entail other angles, including including I think the heart of everything is really the functionality, ensuring that the whole ecosystem is really connected and functioning together, and connectivity is one element. Yeah.
Yes, I think it's a very good point, and hopefully after the break of, I don't know if we still have a break, but we're going to present things that go in this direction, and I hope that the discussion we're going to have on day 3 are going to go in this direction, like even just looking at marine functional connectivity, we need to link it to ecosystem functions in order to go further.
Thank you. Thanks to everybody. I think it's been raising lots of interesting new points, both Elena and Maria's presentations.